we're going to look at Pythagoras' theorem. Now it's really important to note that this only works for right angled triangles. And Pythagoras' theorem is a squared plus b squared is equal to c squared. I want to start by looking at where this actually comes from. So we've got a right angled triangle. We can label this first side down the bottom here A. Now if I was to take this side length A and square it, I would end up with this area here, A squared. This second side length, I'm going to call it B. I'm going to take it and square it, and I'm going to end up with this area here, this square area, B squared. And what Pythagoras has found is that if you took both of these areas from squaring the two shorter sides of a right angled triangle together and added them, that they would both fit perfectly into the square of the longest side, which we call C in Pythagoras' theorem. So that's where it comes from. And we can use this to help us to find missing lengths. Now before we do that, we've got to be able to identify what we call the hypotenuse. Now the hypotenuse is the mathematical name for the longest side of a triangle. In order to be able to identify that, we first need to identify the right angle, which is where two sides of the triangle meet perpendicularly at a 90-degree angle. So we can pop that onto the diagram here. Find this corner here, I'm going to pop a black dot there, because it helps us to identify the hypotenuse by pointing the way. The hypotenuse is always the side opposite the right angle of a triangle. Okay. So now that we can identify our hypotenuse, we need to be able to use this to find missing side lengths. We know that a squared plus b squared is going to equal c squared. Looking at our triangle here, there's my right angle. It points the way, always opposite. So x must be our hypotenuse. We're trying to find the long side, that's our missing side. Following this rule here then, we're going to say that 9 squared plus 6 squared is going to give me c squared. Nor 9 squared is 81 and 6 squared is 36. And that is going to be c squared. Adding those together for 117. C squared is 117. It's really important to know that this is not the answer that we're looking for. We don't want to know what c squared is, or in fact we could call it x. We're actually after just c or x. So what we need to do here is to take it from a squared back, we need to square root. So we're going to square root 117, and that is going to give me my c, or in this case x. The square root of 117, your calculator might give it to you as a third. If you want it in a decimal, you need to push your S to D button. And then I really would recommend that you write out your entire calculator display, especially in exams, before you do anything else with it. I'm going to just write the answer to 2 places of decimal. Now, I find that this is, it's a completely and utterly correct way of working out the longest side of a triangle using Pythagoras. But I do find this quite a long process. Students often make mistakes, such as not square rooting at the end and saying that the answer is 117, amongst other things. So I've found an easier way of doing this for me personally, so that I don't sort of forget to square root at the end, is I square root at the beginning. So we could use this process, the square root of 9 squared plus 6 squared, and if you pop that into your calculator like that and just push the equal sign, you will get the same answer, which I think is a much quicker and easier way of remembering how to get the answer to this question. Moving on then, so we've just looked at finding a long side. We can also find the short side. Now, if to find a long side we have to add the squares together, finding a short side we have to take the short side that we have away from the hypotenuse. So let's just double check. It's definitely a short side we're looking for. There's my right angle pointing the way. Yeah, this is my hypotenuse and I have a value for it, so I'm definitely finding a short side. Now we can use whichever method we prefer. So we could say 14 squared take away 9 squared is going to give me x squared. I'm going to use x instead of a or b. 14 squared is 196. Take away 9 squared, which is 81, gives me x squared. 115 is equal to x squared. Remembering now that we must square root, because we don't want x squared, we want x. Writing out our entire calculator display for our examiner. Before we do anything else with it, again, I'm going to just write that to 2 places of decimal. If we wanted to use the shorter method, square root into our calculator at the very, very beginning. 14 squared minus 9 squared into our calculator, and that will give you the same result. My top tip is really important to note here. I always recommend to my students that they put the larger number first at the beginning when we're doing this, regardless of whether we're finding a short side or a long side, because it won't matter when we're finding a long side, but it will matter if you try to take these away in the wrong order when you're finding a short side. So always pop the longest one in first. If you want to pause the video here and give these a go just to check your understanding. Fantastic, so you should have found that these were the answers that we were looking for. That first one, finding a short side, so it's a takeaway. Second one, finding the hypotenuse, so it's an add. And that last one, another short side, so another takeaway. Now, it's important to note that you might be asked to do other things with Pythagoras during your exams. I'm not going to look at everything, but I'm going to look at a couple of different types of ways in which examiners might expect you to use Pythagoras. They might ask you to find the distance between 2 points, for example, and this might not, automatically make you think of Pythagoras. But if I was to pop that line there, this is the distance between these 2 points, you might sort of already be starting to see that actually we could put another couple of lines onto this grid and make a right angled triangle. And then to find this distance here, I'm just going to label that x, we can actually use this right angled triangle here, finding the hypotenuse. By seeing how far along the x-axis this bottom length goes, 1, 2, 3, 4, 5, 6. 6 squared. It is the hypotenuse we're finding, so it will be addition, and then how far up this other side it goes, 1, 2, 3, 4, 5 squared. Popping that into our calculator for an answer of 7.810249. 676, writing out the entire calculator display, and then if we wanted to just round that to 2 places of decimal, 7.81. Something a little bit more confusing, the examiners really do like to sort of mix Pythagoras up with other things that you might be expected to know about. So we've got a circle here, we can quite clearly see our right angled triangle, but we've also got a circle and quite a wordy question to go with it. So let's have a look. We've got L is the point on a circle with centre 0 and a radius of 5.6 centimetres. Now I would be starting to draw things on the diagram here to help me. So we're told that this is the radius, O to L is the radius, and we're told that's 5.6 centimetres. So I'm just going to pop that on the diagram to help. We're then told that LM, this line here, LM, is the tangent to the circle at L. Now tangent, that tells us that actually this is a right angle because tangents just touch the outside edge of a circle at a right angle. So that's where our right angled triangle is, just confirming it's a right angled triangle. And then it tells us that the length of LM is 7.2. So we're just going to write that on there as well. We're then told that OM intersects the circle at N. And we're asked to calculate the length of MN. So actually we're not being asked to calculate the side length of this triangle, but just this portion here. Now, with the information that I've got, I'm not going to be able to do that just yet, but what I can do, because this is a right angle triangle, is use Pythagoras to calculate the length of this hypotenuse, and it is a hypotenuse because this is opposite the right angle here. So, putting that into our calculator, we're going to do the square root of 7.2 squared add 5.6 squared, and that's going to give me an answer of 9.12. I'm going to write the entire calculator display out here. I would keep this in my calculator because we're not quite finished yet, so don't get rid of that from your calculator. Right, okay, so how do I go about finding out this? Well, what do we know about circles? We know that the from the middle of a circle to its outside edge is a radius. We've already been told that this radius is 5.6, so actually this section here is also going to be 5.6, and if I take that away from the length that I've just found, I'm going to find the missing portion that I've been looking for. And then it's asked us to write it correct to 3 significant figures, which would give me a total answer of 3.52 centimetres.